Hello everyone. Now this is very exciting because we will see how we can deploy an AI model, machine learning model with very easy library that is called gradio. So here I am in the gradio.app where you can go ahead and try out some already existing model on the web, on the gradio website. For example, here we got sketch recognition, question answering, image segmentation, and as you can see, this is using the using Python, using the gradio library, and it is very easy to deploy your any kind of machine learning model. So to define gradio is an open source Python library that is used to build machine learning and data science demos and web applications. With gradio, you can quickly create a beautiful user interface around your machine learning models or data science workflow and let people try it out by dragging and dropping in their own images, for example, pasting text, recording their own voice, and interacting with your demos all through the browser. Okay, so in today's tutorials we will try out gradio using Python code, and exactly I will be talking about image classification in TensorFlow and Keras, and you can find this tutorial on the gradio docs. Okay, so let's go ahead and let's get started directly. So here I got a new Google Collaboratory notebook is opened here, and that so that we can directly install the gradio library using pip install -q gradio. Okay, and then we will import TensorFlow as tf, and we will define MobileNet version 2, okay, that uses the tf dot keras dot applications dot MobileNet version 2. Okay, let's run this code to see if it is correct. It is not correct, so maybe I got this wrong. Here we need s. Okay, yeah, so great. So this line creates an instance of the MobileNet version 2 class from the tf.keras.applications module, and MobileNet version 2 is actually a pre-trained deep neural network model developed by Google that has been trained on the ImageNet dataset to perform image classification tasks. So by creating an instance of the MobileNet version 2 class, we are instantiating the model architecture and loading its pre-trained weights so that we can use this model later on with our gradio app. Okay? Now, next step is to get or fetch the labels of the model so that we can use it to get confidences out from the model when we test any picture. Okay, so let's write this code that does the things that I said earlier. So first we import requests, and then we define response. Okay, and by requests library we get from the following URL: https://get.io/jjk and yn. Okay, so please make sure to type this correctly if you are typing with me. This is the URL for the dataset. Here, this is JJ capital and K small, YN capital. I think I need to check if this is correct one. Let me check it here. So this should, yeah, return the 1000 classes of the or the labels, 1000 classes labels of the ImageNet dataset. So next step is to define labels, and from response we get to the text, and then we split by the /n. Okay, let me type it here, /n. Okay, so that to explain this, we first, as you can see, imported the requests, and which is a very popular Python library for sending HTTP requests, and then we define the response. Okay, so this line sends a GET request to the specified URL, to this URL, which returns the label for the 1000 classes in the ImageNet dataset. So the response from the request is stored inside response here, and then this line splits the response text by how to say, by line breaks, and stores the resulting list of labels in the labels variable. Okay, so right now we need to define a new function that classify an image. So classify image that takes input, and then we want to reshape this input because this is a numpy data. -1, let's define -1, 2 to 4, 2 to 4, and 3. Okay, input equal tf.keras dot applications, okay, dot mobile net version 2 dot pre-process input. Okay, and for we give it this input above. Okay, and then we need to define prediction, of course, prediction, where we will use the mobile net. We'll be using this model above to predict the from the input data, and then we make flatten. Okay, we do flatten on the input. I will tell you why we do flatten later. So, and then we define confidences. We define a dictionary of confidences that will loop through the predictions here of I. Okay, for I in range, I think 1000. Let me check. Yeah. Okay, and then we need, so this is the prediction. Should be without s, just predictions, and this labels should be from this one, label. Okay, and we need to return the confidences so that we can use it in our for our model. Okay, or for our gradio function. Okay, so here to explain to you what's happening in this function, first we are so this line define the classify function, as we said, that takes as an input an image represented as a numpy array, imp. We defined it to be named imp, and then we this line reshape the input numpy array imp to match the required input shape for the MobileNet version 2 model, which is the exact this format. Okay, the value -1 here for the first dimension means that the number of examples is inferred by from the length of the array and other dimensions. Okay, now this line of code here applies the pre-processing function where we pre-process input, okay, from the tf.keras.applications.mobilenet version 2 module, okay, to the input image, so that the purpose of the pre-processing is to standardize the input image so that it can be fed into the model. Okay, and then this line uses the predict method, as you can see here, of the MobileNet, of course, version 2 instance model, to generate a prediction for the input image. Okay, and then the flatten method here is used to convert the or to convert to convert from two-dimensional array to one-dimensional array. So the resulting one-dimensional prediction is stored inside the prediction variable, and then we use this line of code to create a dictionary, okay, confidences that maps the label 1000 in ImageNet to the corresponding confidence scores in the prediction, so that the confidence scores are converted from strings to floats, as you can see here in this function, and so that we can return confidences as the output of the image classify function. I hope this makes sense. And then if we run this, okay, we get nothing until now. So the next step is to import gradio as gr here, okay. Then we will be using gr.interface interface. We will take as a function classify image here, and then as inputs we will get gr image of type shape the same as our model will accept, which is 244, and then for the outputs we need outputs also. Define our outputs gr.label okay, and number of top classes to be 3. You can choose whatever you want. So I will be getting only the 3 best confidences, and as examples here I will give banana.jpg and also car.jpg. You need to provide also your own images. Then we will launch the model or the web using that will use our model using the gradio. Okay, so here as you can see, let's try test it. So here as you can see we got banana. If you want to open the URL, then I think it is going to be shown better results. So yeah, submit here, we get 97% for this image classified as banana. And for the car, let's test submit, and we got sports car. Also you can here, for example, try to drag and drop certain image here, submit. So yeah, this is African elephant, 61%, and 30%, 13% to different categories or different classes. Okay, so here also you can let's say it like the library says to create a public link, set share to true. So you only change this to true, share to true, I think. Let me check this. Yeah, share to true. Let's run again. Now this is will generate a public link so that you can share it with people all around the world. Anyone has an internet access can access to your model and try it out and give some feedback. Okay, so this is a public link. And also, moreover, you can, for example, if you want to specify only for few people to test out your model, then you can define, for example, authentication, where you can give a username and password. For example, let's say username Gaith, my name, and the password is 123. Let's test, run again and test this. Okay, let's go to this URL, and for example, let's type my name. Maybe let's add one more letter, and let's type the correct password, login, so incorrect with credentials, and then let's type correctly again, 123, and this should be open. Okay, so you see the password is 123. Okay, So as we can see here, also we can test it again. Yeah, so this is everything. And if you need more, if you need more information, or if you want me to continue working on such a library, please let me know. And thanks for watching.